As Dr. Barnes here. Let's solve this question using what we just learned in Fourier transforms. Okay. So first, let us plot our signal. Okay. So our signal is x of t equals e exponent minus at into u of t. Okay. So we are aware that this signal here, this place is what? X of t. Okay, and here is t. Okay, and then u of what? U of t. Okay, that means that it will start. U of t means that t is equals to 0, so it will start from here. Okay, and this signal, the amplitude, the highest amplitude is always 1. So it will start from 1 in this way. It will not touch the x-axis, but it will be very close to it. All right, it will not really touch this axis, but it will be very close to it. So e minus at into u of what? Of t. Okay, so this is a signal. So here is 0, and then it will be approaching what? Infinity. Okay, so here we are supposed to solve this question with what? Fourier transform. So we know that Fourier transform, as we derived, is x of w is equals to summation into what? Infinity minus infinity. Okay, we have x of what? T into e minus j omega what? T dt. Okay, so here x of omega, okay, is equals to here we're starting from 0. So 0 to what? Infinity. Okay, 0 to infinity into x of t. What is x of t? X of t is actually equals to what? E minus a what? At. Okay, into this we have u of what? T into e minus j what? T. But this u of t actually is a unit step signal. The u of t is a unit step signal, which is what? 1. So this one becomes this one 0 to what? Infinity. E minus what? At into e minus j what? T. Minus jwt into what? The t. Okay, so it actually becomes like this. Okay, it actually becomes like this. So now when it becomes like this, then what I can say is that x of w is equals to this, okay, into what? E. Okay, into e minus, I can bring minus out. Okay, minus out, then I can have what? A, okay, plus a plus j omega. Okay, a plus j omega into what? Into t. Okay, the t. All right, so this is what I'm going to have. Now when I have this, what I can just do is that I can just simplify. I can just integrate it. So if I'm integrating a function like this, I will get what? 1 over what? I'll get minus 1. Okay, I'll get minus 1 over a plus j omega. Okay, into e exponent minus what? Minus a plus j omega. Okay, into what? T. Okay, so here I'll just introduce my limit, which are 0, and then which are what? Infinity. So if I'm introducing my limit, then I'm going to get x into omega is going to give me minus 1 over a plus j omega. Okay, into e exponent what? Into e exponent minus a plus j omega. Okay, into what? Infinity. Okay, and then I'm going to have what? E exponent minus a plus j omega into what? Into 0. Okay, so this is what I'm going to get. So now x of omega is going to be equals to what? Minus 1 over what? A plus j omega. Okay, into what? E exponent minus infinity minus e exponent what? 0. which is actually equals to minus 1 over a plus j omega into what? E exponent minus infinity is actually going to be 0. Okay, it's actually going to be 0. It's 0, and then e exponent what? 0 is what? 1. So minus what? 1. All right. So minus this minus will make here what? Positive. So I'm going to have what? X into what? Omega. X of omega is equals to 1 over what? 1 over a plus j what? Omega. Okay, so this is going to be my answer. Okay, so now after finding this one, then I can find the modulus of this one. So the modulus of this one is such that x of what? Omega modulus, okay, is going to be what? 1 over a plus what? Omega squared, okay, all into what? Roots. Okay, so that is my modulus. All right, that is my modulus. Okay, so now from here, what I can do again is that I can now plot my frequency spectrum, and then also I can now plot my phase spectrum. Okay, all right. So now the phase spectrum that we're going to plot is going to be a plot of the angle, okay, a plot of the angle, and then also with respect to the frequency, okay. So it's going to be a plot of the angle with respect to the frequency, okay. So and then the other plot, which is the magnitude spectrum, that is going to be a plot of the frequency with the with a plot of the frequency with the amplitude, okay, with the amplitude. Okay, so now let's just go ahead and then see what we can do here. So here I'm going to have x of omega, okay, here the absolute or the modulus, okay, versus omega, okay. So now I can determine values for what? Omega, okay, and I'm actually using this formula that x of what? Omega, okay, is equals to 1 over what? A squared plus what? Omega squared. Okay, this is the formula I'm using. So now let's say that omega is, assume a value for omega. Okay, so now let's say that omega is 0. If omega is 0, here is 0, then you have what? 1 over a, 1 over a square root of a squared. 1 over square root of a squared will give you 1 over a. Okay, now let's say that omega is minus infinity. If omega is minus infinity, and then you have 1 over root of minus infinity, then you're going to get 0. Because root of minus, because 1 divided by, if omega is minus infinity, okay, so minus infinity squared, 1 divided by, if here is minus infinity squared, then plus this a will become what? Infinity squared. So 1 divided by root of infinity squared will be what? 0. And then if a is what? Infinity. So infinity squared plus a squared will become what? Infinity squared. 1 divided by infinity squared will be 0. Okay. So this is what we're going to get. Okay. This is what we're going to get. So now from here, we can just plot our frequency spectrum. So here, this is a plot of the frequency spectrum. Okay, so here I'm just dealing with the frequency or the magnitude. Okay, frequency spectrum. Okay, so here it's going to be this way. Okay, it's going to be like this. Okay, all right. So it's going to be this way, and then here it's going to be omega. Okay, and then here it's going to be what? X of what? Omega. Okay, like this. Okay, so now here is going to be what? 0. Here is approaching infinity. Here is approaching minus infinity. Okay, so here the highest amplitude here is going to be what? 1 over a. Okay, 1 over a. So here see that 1 over a is 0, 0. And then we have what? 0, we have 0, and then minus what? Infinity. So minus infinity is here, 0 is here. Okay, so that means that this one will have to come somewhere close, but it will not really touch. Okay, and this one will come somewhere what? Close. Somewhere close, but it will not really touch. Okay, so this becomes what? The phase, the frequency spectrum, or the magnitude spectrum, as it's popularly called. Okay, now let's see about the phase what? The phase spectrum. Okay, so the phase spectrum, what we're going to have is that we're going to have the angle. Okay, so the angle here is x of what? Omega. Okay, so this is how we represent the angle. Okay, which is equals to minus tan inverse. Okay, minus tan inverse of omega into over a. Okay, minus tan inverse of omega on what? A. Okay, so let's say here we have omega here, and then here we have x of what? Omega angle. Okay, so let's assume values for them. So let's say omega is what? 0. If omega is 0, then what happens to the x of omega angle? Okay, so then the angle will become tan inverse of 0. Okay, and what is the tan inverse of 0? The tan inverse of 0 is actually what? 0. Okay, so now let's see if omega is minus infinity. Okay, if omega is minus infinity, then the tan inverse of what? Minus infinity. The tan inverse of minus infinity is minus pi on 2, but there's an minus here already. So it becomes what? Positive what? Pi on 2. Then here, if omega is infinity, then infinity over a, tan inverse of infinity is what? Pi on 2, but the negative here will make it what? Negative pi on 2. So with this, we can just plot our phase spectrum. So this is the phase spectrum. Okay, so this one, all right, which is what? Omega. And then we have this one, okay, this one, okay, which is what? X into what? Omega. Okay, all right. So now here we have pi, we have 0, 0. Okay, then this is what? 0, 0. And then we have pi on 2 and minus what? Infinity. So here, this minus infinity, to plot this one, we have to imagine that we have just what? Pi on 2, 0. Okay, so if you have pi on 2 and the pi on 2 is on the y-axis, then in that case, we have to plot it this way. Okay, and then we have minus what? Pi on 2 also. That in that case, it has to be what? This way. Okay, but here is what? Positive infinity. Here is what? Minus infinity. So now, here is what? Pi on what? 2. Here is minus pi on what? 2. So now here, minus pi on 2 and then pi on 2. So pi on 2 and minus infinity. Okay, so pi on 2 minus infinity. That means that it will have to come from somewhere here, because this pi on 2 and this minus infinity. Now, minus pi on 2 and positive infinity. Okay, that will be somewhere here. So that means that our curve will be, it will close, but it will not touch. Okay, so this becomes what? Our phase what? Spectrum. All right, so this is how our phase spectrum will look like. Thank you so much. I'll see you in the next class.